Welcome to Convergence Data Classification Community Group. Today's topic will be component and supplier data management, top issues to avoid. Typically, the way one of our classification community groups works is that we will have a 15-minute presentation followed by a Q&A. Our key learning points today will be mitigating high supplier pricing, misclassifications of spend, too many vendors by category or sole sourcing, integrating technical and commercial data. My name is Megan, and I will let Richard kick us off.
Hi, everybody. Before we get started, just a quick introduction of Convergence Data. We've been in business for 20 years, and we've been focused on parts classification and master data management across the following industries. So what we do as both a service and a solution as a service, we will take a customer's parts, which can be design parts, purchase parts, MRO items, or even products, and we can prepare them and enrich them through a classification process. Typically, we're engaged in a customer's ERP or PLM deployment or PIM deployment. Quite often, we're engaged to support engineering reuse of parts, to mitigate duplicate parts and parts proliferation. And on the procurement side, help with cost reduction of direct materials, which is one of the focuses of today's discussion. So when talking to a lot of our customers, these are some of the business challenges that they typically have. One thing we've seen is they will have more than one place they can create new parts. They may have multiple PLM systems, and they may be creating parts, new parts, independently of each other, which is a major issue. And because of this, they end up with a part proliferation issue. And what does that mean? Well, the parts that go in your bill of materials are classified as direct material spend. The direct material spend is typically one of the largest expenses a manufacturing and engineering organization can have. One of the sources of driving that spend is the proliferation of parts. And lastly, engineering and procurement are typically not on the same page. They're not working together, kind of managing a joint category strategy, where they're determining category by category what's the best thing the company should do. We've isolated, for today's topic, we've isolated 7 issues we'd like to discuss and kind of drive the business challenges I was just talking about. One is procurement typically lacks the information they need to source new parts. So it's always a difficult process when a new part comes up for sourcing to get all the data they need from engineering. Engineers, on the other side, will sometimes engage suppliers for a new part that might not even be approved suppliers. So they'll be working independently in procurement, going down the path with a supplier that may not even be approved. And this leaves procurement with this issue where they may have too many suppliers for a particular category, or they may not have enough. They might be in a sole source situation, and they're not able to work out backup suppliers for certain categories. Another issue we see is quite often within a category, for similar parts, they might have completely different prices. They may vary widely. They may also lack data to really challenge the unnecessary high pricing they may be getting from suppliers. It's not easy for them to compare prices of other similar items because they may lack the data. And for the larger companies that have different locations around the world, they may be buying similar items from different suppliers, usually local suppliers, at different prices. And lastly, which a lot of companies like to be able to do is what we call market basket sourcing. They're not able to cluster or group similar parts in a large sourcing event like a market basket to achieve the cost savings you get when you bring together all those parts into a single sourcing event. So why don't we start? Megan is going to show you a demonstration illustrating some of these challenges. But right now she's in our search tool called SmartFind, and she's simulating what it's like for someone who hasn't classified their data and they need a new raw material. In this case, it's a tube. So first of all, they should be searching to see if they have any tube in inventory today that may already exist. So she's going into the raw materials category and then looking at all the tubes that their particular company has purchased over the years. And sure enough, they've purchased over 14,000 tubes. So they have plenty of tube in inventory. But here's the challenge. The only information Megan has, because they haven't adopted classification, is a part number and a description. And the description has very limited information in many cases. This makes it very challenging for her to reuse an existing tube. Despite having 14,000 in inventory, she's forced to create a new part because she does not have the time to go through each one of these to figure out which one would meet her requirement. So this is the worst case scenario. What we recommend to avoid a situation like this, we're going to rerun another search based on data that's been classified. So now she's going to look for an AC motor. She enters AC motor, and very quickly, because they've adopted classification, she's able to find the category. Not only can she find the category, she has all these attribute filters on the left side of the screen. You can see these technical attribute values that she can use as filters under power rating. So she can select a specific power rating and shrink this result of 127 motors down to 2. And then she can continue to refine the search result by selecting other attribute filters to get to the specific motor she wants. And within a couple of clicks, she's found the motor she wants. So that's the value of having the technical data, which is all this metadata you see on this screen, the string data, the numeric data. All this information makes it easier for both engineering and procurement to kind of manage their data category by category. Another interesting thing is there's another tab here next to details that says pricing. This is kind of the premise of today's discussion, is look at the value of combining the pricing with the technical attribute data. So in this example, under pricing, we have 3 different plants and vendors that are buying this motor today at 3 different prices. You can see under vendor name, all the vendors, and you can see under plant name, all the plants. And you can see the prices vary quite widely. So for the division in China, they seem to be getting a much better price than the division that's in the US. So this exposes some opportunities for cost savings, because now you've got the technical attribute data and the pricing all merged together. Another thing she can do is go back to the category, and not only can she filter on the technical attribute data, see the pricing attributes to the left at the bottom of the technical attribute data? She's going to look at and profile this category and look at what vendors provide these motors. She can sort on the vendors. So she's selected General Electric, and you can see that there are 17 motors that they're buying from General Electric today. She can also do a similar search by profiling what plants are buying these. So if she selects USA Florida, she can see that their Florida location has bought 26 of these motors. So you can get a profile of what plants are buying a certain item in a certain category, or what vendors you're buying from and what price you're paying. So this is the value of having technical attribute data and pricing merged together for both engineering and procurement. So another thing that we'll do once we've merged these two data sets is we can do a cluster analysis, which I mentioned earlier. You can't do a cluster analysis unless you have the technical attribute data. And you can see at the top of this chart, you can see there's attributes like length, head type, and material that have weight factors. We've set the weight factors in our clusters tool, and then we've run it, and it produced this chart down the bottom, which shows you the results of a cluster. There's a cluster of 30, these are fasteners, that have all very similar attribute values. Maybe they're slightly different, but different prices that are being purchased from different suppliers. So this is the information that the procurement group could use if they wanted to do a market basket sourcing event, or just get better alignment with some of their suppliers on these high prices. This is the value of having this information and doing a cluster analysis. So if you don't have this structured data today, what do engineers do when they need to find a part? They can't find a part, like that example where Megan couldn't find a tube. They'll just bring up their browser, go to Google, or go to a supplier website, distributor website like Grainger. The reason why I reference Grainger or McMaster-Carr is they've adopted classification. They make it very easy for an engineer to find a part. And you can see in this example for a screw, once you're on their website, you can quickly pick the type of fastener that you're interested in, and then filter on the attributes to get to the specific one you need. And that typically will become the new part that that engineer wants to introduce to your PLM system. So this is an easy way for them to do it. If their data is poor, this basically what leads to the part proliferation issue. The engineers will bounce out to these websites and just introduce a new part number. Another value of having all your parts categorized is you can start to profile the category by other elements like we were talking about earlier, like manufacturer name. For this particular category, you can see that there are 3 vendors that provide about 50% of the spend for this particular category. You probably want to mark those 3 vendors as your preferred suppliers. And then the rest of these vendors, which they're only seem to have less than 5%, maybe some of them just have one part, you might want to rationalize those vendors with your preferred vendors, so that you don't have so many suppliers to manage for that category. So once you have your parts categorized, this is a useful exercise to help with getting better pricing from your preferred suppliers and consolidate some of these one-off vendors. You can also profile that same category by what we have here as factory code or manufacturing location. This basically gives you a profile of where what division is buying the most of a certain item. You can see there's 3 or 4 divisions that are buying most of the items for this particular category. And you probably get a pretty good idea of where most of the volume is coming from, who's spending the most on certain categories of items. And that might help you with aligning your spend with the vendors that are getting the most volume and the best pricing. So to summarize the benefits of parts classification with commercial pricing data, on the engineering side, it's about getting engineers to reuse parts. And why do we do that? We estimate that every new part number costs the company about $10,000 in life cycle costs. That's the cost to design the part, procure the part, all the material handling costs, the inventory costs, minimally $10,000 it costs for each new part number you introduce. And then on the supply chain side, with this structured data, you can do things like market basket searching, market basket sourcing and clustering. And it just gives you a much better opportunity to get better prices from your suppliers when you can look at what you previously sourced and what you expect to spend from this additional data. So that puts sourcing and procurement in a much better position to kind of manage the direct material spend. So it benefits both organizations. We have a case example on our website. This screenshot down below shows a case example. It's called a DVA report. If you want additional information on this process, I recommend looking at those case studies, and they talk some more detail on the benefits. So in summary, the benefits of classification are pretty vast, from normalizing your data across all the different divisions, having just one set of material codes, material specification, material names, just normalizing that information, implementing one governance process in one place to create new parts so that engineering and procurement are working together to approve new part requests, making it easier for engineers to find and reuse parts, they don't have to spend as much time looking when they've got the data they need to find parts, helping supply chain rationalize their spend, less suppliers, better price alignment, standardizing on units of measure, exposing duplicate parts and preventing those from being migrated to, say, your new ERP or PLM system. If you're about to deploy a new ERP or PLM, recommend you do a duplicate analysis so you're not bringing that duplicate inventory into those systems. And then lastly, for your PLM system, by having classification data, it just makes it that much easier for engineers to share parts. As I mentioned, on our website, convergencedata.com, you can find some additional DVA case studies like the ones that we were talking about today. We also have some best practices blogs in our blog section under our classification community group. We have videos that you can look at, and we also attend conferences, PLM and ERP conferences. You can find us there. So that being said, that concludes today's presentation. If you have any questions you'd like to ask us, now would be a good time. And if you don't want to ask a question today and you want to follow up, you can send me an email. My email address is at the bottom right of the slide.